Picture this. You're standing on the edge of a volcanic cliff, the salty wind whipping against your face as you peer down at an island shrouded in mist. Everything appears tranquil until something moves in the undergrowth below. A shadow so massive it shouldn't exist. Not here, not anywhere. A creature the size of a small car, yet it's nothing more than a rat. Or perhaps it's a bird, flightless and fearless, waddling through the forest with the confidence of an apex predator, despite having the evolutionary blueprint of a pigeon. This isn't science fiction, this is the island rule, and it's one of nature's most mind-bending experiments. If you've ever wondered how evolution can throw its own rulebook out the window, you're in the right place. Hit that like button and subscribe, because what you're about to discover will completely change how you see the natural world. Trust me, by the end of this journey, you'll never look at islands, or their inhabitants, the same way again. When we imagine remote islands, our minds conjure images of scarcity, limited land, sparse food, harsh conditions. Logic would suggest that animals living in such environments should evolve to become smaller, more efficient, and better at conserving precious energy in a world where every calorie counts. But nature, as it turns out, has a wicked sense of humor. Across hundreds of islands worldwide, evolution has done the exact opposite. Small animals balloon into giants. Large animals shrink into pocket-sized versions of their mainland ancestors. It's as if nature looked at its own rules and decided to conduct the wildest experiment imaginable. Scientists call this phenomenon the island rule, and it reveals something profound about how life adapts when all the normal pressures of survival suddenly vanish. The island rule manifests in two spectacular directions. First, there's gigantism, where creatures that should fit in the palm of your hand grow to the size of house cats or larger. Then, there's dwarfism, where massive mainland species shrink down to almost comical proportions. Both trends seem to contradict each other, yet they're driven by the same fundamental forces that exist only in island ecosystems. So what creates this evolutionary playground? Three critical factors work in concert to reshape life in ways the mainland would never permit. The first and most powerful force is the absence of predators. On continents, small animals live under constant threat. They must stay small to hide in crevices, to flee quickly, to avoid detection. Every gram of extra weight is a liability when a fox or snake could appear at any moment. But when that same species washes ashore on an island with no predators, the entire calculus changes overnight. Suddenly, being larger isn't a death sentence, it's an advantage. More body mass means better temperature regulation, access to previously unreachable food sources, and dominance over competitors. The second force is ecological opportunity. Islands are like vacant real estate in nature. Many lack large herbivores, top predators, or entire groups of mammals that dominate mainland ecosystems. When a bird or rodent arrives and finds these roles completely empty, evolution doesn't hesitate. That newcomer begins to fill the void, even if it means transforming beyond recognition. A mouse becomes a pseudo-predator. A parrot becomes a flightless grazer. The niche demands it, and isolation provides the time to make it happen. The third force is genetic isolation itself. Island populations are small, often descended from just a handful of individuals. This creates what scientists call a founder effect. If those first arrivals happen to be larger than average, that trait can rapidly spread through the entire population. With no gene flow from the mainland to dilute these changes, evolution accelerates. Mutations that would be washed away in a continental population can become fixed features within dozens or hundreds of generations. When these three forces align, islands become evolutionary laboratories conducting experiments that would never survive on the mainland. And nowhere is this more apparent than in the birds. If you want to understand island gigantism at its most extreme, look to the birds. These creatures evolved flight specifically to escape danger and find new territories. Yet, when they land on predator-free islands, those very wings become expendable. Over time, species after species chose the ground over the sky, trading aerial agility for size, strength, and terrestrial dominance. Let's start with perhaps the most famous victim of island evolution, the dodo. Today, we remember it as a rotund, clumsy bird, the poster child for extinction. But here's what most people don't know. The dodo began its evolutionary journey as a pigeon. Yes, a pigeon. Its ancestors were small, agile flyers capable of crossing vast stretches of ocean. When they reached Mauritius millions of years ago, they found paradise, no predators, fruit falling from every tree, and zero competition. The transformation was dramatic. Over countless generations, dodos grew to nearly 18 kilograms, more than 30 times heavier than a common pigeon. Their wings, once powerful enough to carry them across the Indian Ocean, withered into decorative stubs. Their beaks thickened and strengthened, designed to crack open tough seeds and fruits. Historical accounts even describe their bite as surprisingly powerful, suggesting they were far more capable than later caricatures suggested. For thousands of years, this strategy worked flawlessly. The dodo ruled its ecosystem, unbothered and unchallenged, but evolution had created a creature so specialized for safety that it lost all concept of danger. When Dutch sailors arrived in the late 16th century, dodos didn't run. They didn't hide. Some even approached out of curiosity. Within 80 years, they were gone forever, victims of their own evolutionary success. But the dodo wasn't alone in its transformation. About 560 kilometers east on Rodrigues Island, another pigeon had evolved into something completely different, the Rodrigues Solitaire. If the dodo was the peaceful giant, the Solitaire was a gladiator. Standing nearly 90 centimeters tall and weighing up to 28 kilograms, solitaires were even more massive than their dodo cousins. But size wasn't their most remarkable feature. Inside their vestigial wings, they had developed something unique. Two hard, bony masses the size of ping-pong balls. These weren't evolutionary leftovers, they were weapons. 18th century accounts describe solitaires battling each other with wing strikes so powerful they sounded like thunder echoing through the forest. Fossil evidence backs this up, showing numerous healed fractures on their bones, battle scars from fierce territorial combat. Why were they so aggressive when their dodo relatives were so placid? The answer likely lies in the environment. Rodrigues was drier and more resource scarce than Mauritius, forcing solitaires to fight for every meal and every nesting site. Like the dodo, the solitaire's evolutionary adaptations couldn't save it from human arrival. By the mid-18th century, they too had vanished, leaving behind only bones and stories of the thundering bird that once ruled its island domain. If giant flightless birds seem incredible, wait until you hear about the rats. When you think of massive animals, rodents probably rank somewhere below goldfish on your list. But islands tell a very different story, one where mice transform into beasts that would make a terrier think twice. On Tenerife in the Canary Islands, there once lived Canariomys bravoi, a rat species that grew to 5 times the size of its mainland relatives. We're not talking slightly larger, we're talking Yorkshire Terrier large. Fossils reveal skulls and teeth designed to crush seeds and tubers that normal rats couldn't even attempt. Without cats, foxes, or snakes to fear, these rats filled ecological roles typically reserved for much larger mammals. The transformation happened relatively quickly too, just a few 100,000 years. To put that in perspective, that's roughly the same time frame that separates Neanderthals from modern humans. Evolution doesn't always move at a glacial pace. Sometimes, when conditions are right, it sprints. But if you want to see how fast island gigantism can occur, look at the St. Kilda field mouse in Scotland. These mice likely arrived on ancient Viking ships roughly 1,000 years ago. In that impossibly short window, barely more than a few dozen human generations, they've grown significantly larger than their mainland European cousins. The cold, harsh environment of St. Kilda had no predators to threaten them, creating perfect conditions for rapid size expansion. This proves something crucial. Island gigantism doesn't require millions of years. Sometimes, it only needs a few centuries. Perhaps nowhere demonstrates the island rule more dramatically than Flores Island in Indonesia. This single landmass is famous for hosting two opposite extremes of island evolution occurring simultaneously, a natural experiment that seems almost deliberately designed to prove the rule. On one hand, Flores was home to Homo floresiensis, an ancient human species that stood barely 1 meter tall, nicknamed the Hobbit by scientists who discovered their remains. On the other hand, it hosted Papagamys armandvillei, the Flores giant rat, weighing up to 2.5 kilograms, nearly 10 times larger than common rats. Think about that for a moment. On the same island, at the same time, humans were shrinking while rats were ballooning. It's the island rule in perfect symmetry. The rats thrived because Flores had only one significant predator, the Komodo dragon, which preferred larger prey and carrion. With year-round food and minimal threats, growing large became an evolutionary advantage. Meanwhile, the human population faced different pressures that favored smaller body sizes, including limited resources and isolation from mainland gene pools. These gentle giants weren't monsters. They were forest-dwelling herbivores with diverse diets, living peacefully in an ecosystem that allowed them to grow beyond all normal rodent proportions. They remain a living testament to how radically isolation can reshape life. In the absence of the animals that typically dominate terrestrial ecosystems, nature had to improvise with what was available: birds and insects. The result was a world that seemed almost alien. For millions of years, the role of large herbivores was filled by the moa, a group of giant flightless birds. The largest species, the giant moa, stood up to 3.6 meters tall and weighed over 270 kilograms, roughly the size of a small bison. But here's what makes them truly extraordinary. They didn't just lose the ability to fly. They completely forgot they ever had wings. Unlike ostriches or emus, which still have vestigial wings, the moa's skeleton shows virtually no trace of forelimbs. Just a tiny finger-sized bone fragment, the last remnant of what once allowed their ancestors to soar. No other bird species on Earth has erased its wings so thoroughly. For millions of years, these gentle giants roamed New Zealand's ancient forests, grazing on leaves and dispersing seeds, filling an ecological role that mammals would occupy everywhere else, but even 3-meter-tall birds weren't safe. Ruling over the moa from the skies was Haast's eagle, the largest eagle that ever existed. Females weighed up to 18 kilograms with wingspans of 3 meters. Their talons were comparable in size to a tiger's claws, and their body frame was built like a winged lion, compact, muscular, and devastatingly powerful. Fossil analysis reveals that Haast's eagles were capable of direct attacks on moa, grappling and killing prey many times their own weight. Some Maori legends speak of the puakai, a mythical bird that supposedly hunted humans. While we can't confirm these stories with absolute certainty, scientists agree that Haast's eagles possessed enough strength to pose a genuine danger to the first people who arrived in New Zealand about 700 years ago. But when the Maori began hunting moa to extinction, Haast's eagle lost its primary food source. Within a short time, these magnificent predators also vanished, proving that even apex predators aren't immune to the cascade effects of ecosystem collapse. Not all of New Zealand's evolutionary experiments ended in extinction. Some have survived to the present day, though barely. Meet the kakapo, the world's heaviest parrot, and perhaps one of nature's oddest creations. Weighing up to 4 kilograms, the kakapo is flightless, nocturnal, and has a distinctive scent that combines honey with dampness. They use a breeding system called lekking, where males gather in specific locations and emit deep, booming calls that can resonate up to 5 kilometers away to attract females. These calls are so low frequency that they can be felt more than heard. Like the dodo and moa before them, kakapo ancestors were likely medium-sized flying parrots. Upon reaching New Zealand's predator-free environment, they evolved to gain weight, reduce flight muscles, and commit fully to life on the ground. But when humans arrived with cats, dogs, and ferrets, the kakapo had no defense. When threatened, they freeze, a reflex that once worked against aerial predators like eagles, but proved useless against introduced mammals. By the mid-1990s, only 51 kakapo remained alive. Through extraordinary conservation efforts, that number has climbed to 244 as of 2024. But they remain critically endangered, a fragile remnant of New Zealand's lost world. Birds weren't the only creatures to undergo dramatic transformations on islands. Reptiles and even insects have their own incredible stories of gigantism, some of which continue to this day. Take the Komodo dragon, the largest living lizard, growing up to 3 meters long and weighing over 90 kilograms. For years, scientists believed they were a product of pure island gigantism, small lizards that grew enormous in isolation. But modern research tells a different story. Their ancestors were already giant monitor lizards living in Australia hundreds of thousands of years ago. A population migrated to Indonesia, and the island environment helped them retain their massive size while their mainland relatives went extinct due to climate change and competition. The Komodo dragon proves that islands can serve as refuges for giants, preserving body sizes that the mainland can no longer support. Then there's the giant gecko of New Caledonia, Rhacodactylus liachianus. At up to 43 centimeters long and weighing half a kilogram, this is the largest living gecko species. But size isn't what makes them special. It's their personality. These geckos are notoriously aggressive, emitting hisses, growls, and even whistling sounds. They're highly territorial and will attack their own kind, especially during breeding season. This aggression makes perfect sense under the island rule. When competition is limited, being territorial helps secure vital food and shelter resources. But perhaps the most remarkable story of island gigantism belongs to an insect. On Lord Howe Island off Australia's coast, there once lived Dryococulus australis, known evocatively as the tree lobster. These stick insects grow 15 to 20 centimeters long, have stout bodies, and weigh nearly 25 grams. hundreds of times larger than typical stick insects. When you see them, they don't look like insects at all. They look like miniature crustaceans that somehow learned to live on land. In 1918, when rats were accidentally introduced to Lord Howe Island, tree lobsters were thought to have gone extinct. For over 80 years, scientists believed they were gone forever. But in 2001, climbers discovered a tiny surviving population on Ball's Pyramid, a sheer, almost barren rock pillar jutting out of the ocean 23 kilometers away from the main island. No one thought anything could survive there, yet they did. For more than 8 decades, a handful of tree lobsters clung to existence on a hostile sea stack with almost no vegetation. Their survival is a testament to the incredible resilience that island gigantism can produce. These aren't delicate evolutionary experiments. They're hardened survivors that can endure conditions that would kill most species. If you want to meet the undisputed champion of terrestrial invertebrates, the creature that embodies island gigantism at its most spectacular, let me introduce you to Burgess latro, the coconut crab. This is the largest terrestrial crustacean on Earth. With a leg span exceeding 1 meter and weighing over 4 kilograms, coconut crabs look like something that crawled out of a science fiction movie. But what makes them truly extraordinary isn't just their size, it's their capabilities. Despite belonging to the hermit crab family, coconut crabs have evolved past the need for borrowed shells. They've developed their own hardened carapace, freeing them to grow larger than any hermit crab could dream of. Their claws are among the most powerful weapons in the invertebrate world. Studies measuring grip strength have found that their pinch can exert over 3,000 newtons of force, equivalent to a medium-sized lion's bite. That's enough power to crack open coconuts that many vertebrates can't access. But wait, it gets better. These massive crabs can climb trees. They scale coconut palms 10 to 12 meters high to forage for food, moving with surprising agility despite their bulk. And they're famous as island thieves. Locals and tourists regularly report coconut crabs dragging away pots, pans, knives, shoes, anything that smells remotely like food. In some documented cases, they've even attacked and dragged away adult seabirds. Coconut crabs are the perfect embodiment of what happens when small creatures are freed from predatory pressure. Their tiny ancestors could grow without fear, accessing rich food sources and thriving in isolation for hundreds of thousands of years. The result is a creature that exceeds every normal standard of the invertebrate world. Looking back at this incredible journey through evolution's island experiments, one thing becomes crystal clear. Island gigantism isn't random. It's the predictable result of specific conditions. Absent predators, open ecological niches, and genetic isolation. When these factors align, evolution takes paths that the mainland would never allow. But here's the sobering reality. When any one of these conditions is broken, the entire system collapses. The arrival of humans, the introduction of invasive species, or even climate change can unravel millions of years of evolutionary experimentation in mere decades. That's why so many of the creatures we've discussed exist only in fossils and old records. The survivors, the kakapo, the coconut crab, the giant geckos, maintain populations of only a few hundred individuals, clinging to existence in an increasingly hostile world. Island gigantism teaches us something profound about evolution itself. Life doesn't follow a single path. It adapts to whatever conditions it faces, sometimes producing results so bizarre they seem impossible. These island experiments show us that evolution isn't just about survival of the fittest, it's about survival of the most adaptable. And when we lose these species, we're not just losing animals. We're losing living proof of evolution's creativity, natural experiments that can never be replicated. Each extinction closes a window into understanding how life responds to isolation, from eagles that hunted like lions to crabs that can crack coconuts. These creatures prove that given the right conditions and enough time, life will always find a way to surprise us. So the next time you see a remote island on a map, remember, it's not just a dot in the ocean. It's a world where evolution's rules are rewritten, where the impossible becomes routine, and where nature asks itself, what if I started over? What would I create? The answer, as we've seen, is far stranger and more wonderful than we could ever imagine.